So the discussion is related to topic 2.1, which is about the thermal properties of the matter. As you can see, viewed through a microscope, a small particle can be seen moving with a Brownian motion. Brownian motion, a random motion is there. Which line in the table is correct? Type of the motion of the particle. The Brownian motion is it cannot be vibrate, it's a random. And what happened in solid, the particles can only vibrate about the fixed position, but in liquid and a gases, the particle can change the direction as well. That's why C will be the right answer. So the question 2, measured mass of a gas is placed in a cylinder at atmospheric pressure. So the normal pressure is there, and then what happened? Then it is slowly compressed. So what we did, we reduced the volume. So we know, and the temperature does not change. If a temperature does not change, we know the Boyle's law that the pressure and the volume are inversely proportional. If we have a small volume, it means the pressure will be high. So what happened to the pressure? The pressure will increase. So D will be the right answer. Because the pressure and the volume are inversely proportional. In a small space, the particles have more collisions. So as a result, the pressure will be high. But in a large space, the particles will have fewer collisions and the pressure will be low. At a constant temperature, as the temperature does not change. Look, this is representing a heating curve. So when initially, when we label the states, so first we will have a solid. When we further, when there is no change in temperature, it means the solid is turning into a liquid, and we call that temperature as a melting point. Once all of the solid turn into a liquid, so we'll have a liquid here, and then a liquid is turning into a gas. So when liquid is turning into a gas, that temperature is called a boiling point. So which part of a graph shows when a material is boiling? So D will be the valid answer here. So an experiment is set up, as you can see here. What does the pressure gauge shows as the air in the flask become hotter? So if air become hotter means if we are increasing a temperature, we know if the volume is constant, the temperature is directly proportional to pressure, or pressure of a gas is directly proportional to temperature. So higher the temperature, the gas will exert a greater pressure. So there will be an increase in the pressure. So C will be the right answer here. Question 5. Question 5. So in the question, a drop of a liquid falls on a student's skin. Like example, let's say this is a student's skin, and there's a drop of the liquid on the student's skin. So what will happen? The most energetic molecules of the liquid escape. So the molecules which are left behind will have low energy. That's why the skin will cool down. So what is the effect on the skin and the reason? The skin cools because the most energetic molecules escape from the liquid. Because when most energetic molecules escape, the molecules left behind have low energy. That's why it will produce a cooling effect. So if you use a perfume, or when a person sweats, so the body also cool down, because in case of a sweat, what will happen? As the water molecules or the sweat molecules escape, they take the energy and we cool down the body. So skin cools because most energetic molecule remain low. Skin warm, so that evaporation is a cooling process, not a heating process. So A is the valid answer here.